All right, perfect. So
Perfect. Let's start.
Let's start. So what we are planning to do today, okay, I need to check this screen, not that one. What we are planning to do today is, here's Mustafa. Obviously, he will introduce himself soon. And we would like to talk about IT for like not only developers, you know, like we will talk about that. The main reason is what we would like to do, you know, whole sectors are evolving. And like we are touching IT somehow, although we are designer, maybe marketer, software, product manager, project manager, whatever, we're touching the IT. And whenever we talk with an IT guy, we are always says yes, like you know that feeling. So that's why we are here. We would like to talk about these ones, you know. So maybe we will like we are expecting your questions as well. Please prepare from now on. And we will discuss these questions with Mustafa. He is here as a senior software developer today. So that's the thing. So Mustafa, would you like to introduce yourself to our audience?
Sure. Many of us may know me, but I will introduce from start as well. I'm Mustafa. I have been familiar with software programming since my childhood. We were breaking computers and we'll try to build something by trying, manipulating them without a knowledge. After that, I start college. I have been working programming side much closely. I have been developing, I know it from IO. It's a community in our school, so we have been getting around, so developing and sharing our knowledge together. So it was really nice experience to us, and we had chance. We found chance to work new tools because the softwares in schools usually outdated. They teach you to prepare you in a companies in the professional life, but they also use outdated softwares, outdated tools. So we start exploring new tools. For example, Node.js, Python. In that time, it's not that popular. Python, Node.js, crawling, using APIs both. And we start building tools. We start breaking things. So there is some startups came out. People build something, people break something, and that's all starts in 7 years ago, I think. Yeah, it's long time. Yeah. So my journey started that time. So after that, I never lose my connect to programming. I develop, day and night, so you can count 14 years.
Yeah, Umut is here as well. He's saying it was a nice community. Yeah, it was. And then we found a startup together, and it's obviously break up and bankrupt. So anyway, but today you're here as a senior software developer. And what are you doing right now?
I'm working as a DevOps in a company in New Jersey, working from remote. The company is biggest company in the New Jersey, but at the same time, I have been developing. Actually, we have been with a team a product, which is not event or sponsor today.
Thank you so much for that.
You are welcome, always. In the weekdays, I have been working. In the weekends, I have been working another project. So I'm split too.
Okay, you are both software developer, senior software developer, and QA manager. What should I call you? I don't know, but something like that. All right, all right. And me, I'm Cihat. I'm a product developer. Today, I will be the guy who asks like strange
Silly
questions.
questions.
Yeah, like non-engineer one. So we can get started slowly. But is there any questions? Please, like prepare your questions. IT related questions. Please bring up more silly ones. Then we can have some fun in here and learn at the same time. So we are waiting for that as well.
Any questions accepted?
Yeah, like I asked the people like what's their expectation, and what's their occupation here, so we can go in that direction much more. That was my aim. No one answered that yet, but yeah. By the way, I need to check this screen as well. Like this is where the stream and chat goes. So if I'm not looking at here, it does not mean that I'm not looking at you. Actually, I try to interact with you guys. All right. So maybe we can start actually from the zero, like and we can talk about, like, as we are talking about IT nowadays, like software. That's the main topic. Obviously, like when we talk about IT, there are a lot of topics like networking, maybe more IoTs come up and blah, blah. But today we can start from software, actually from top till the software, what is software and stuff like that. And I would like to, okay, actually, there is one question come up during this time. From Daria, are there any free resources where a beginner could learn practice daily? So this is, I guess, a developer perspective question. She would like to be a developer, so that's why she's asking about that. That's a good one. Daria, can you clarify? Are you asking about software development? Just let me clarify that, and we're gonna talk about that. So today, as I said, like we can start from ground up and reach up to software, and a little bit also like from maybe developer perspective, as well as just Daria asked about that, but overall, how is the IT guys? Another question. Okay, we should answer that as well. But overall, what I would like to talk about is we should actually take the perspective of older non-IT people in the team with the IT people as well. So that's the thing. So if you're ready, let's start the first one. Like, are there any free resources? Sorry?
First of all, I have a question for you.
Please go ahead.
How this idea came out? Is this your need?
This
the
my
webinar?
Yeah.
Is this your need?
Yeah, definitely yes. Like I was thinking about, like, you may find a lot of like sources online to start like programming or related with, like, programming and stuff, or related with IT, I would say, overall in a broad perspective, but there is nothing. Like when I search for that, generally they show tools, programming languages and stuff like that, this kind of thing, but they don't give the main idea behind it. Yeah, we may call it as a niche or deep engineering knowledge about that part, but for me it's not. I would like to hear about what's going on there. And the second part is, really, I couldn't find any online source that like shows IT to non-IT people. So that's why we are here, and to talk about that. Maybe we can make it a series, like we can meet every week and talk about that. Or like another thing might be we can maybe make a YouTube series, like a video series, with you, and people might raise questions here right now, so we can understand what they want to hear. So That was the thing. Thank you for the question. And
Welcome.
yeah, let's start with the question of Daria. Dasha, by the way, one more time, thanks to Dasha. She was in the video of us, on Rails from Riga, and she is here right now again. So what you can say, if a person does not know anything about IT, does not know everything about software development, but you can suggest them how they can start.
I mean, first of all,
Sorry for interruption. I guess there is an important point here, which is the free resources. How we can start with zero investment. That's the point, I believe.
I mean, Harvard, there is a free online courses from the Harvard itself. You can also start. You can watch these videos like you are studying computer science. So there is lots of resources, lots of tools around programming. You can develop by practicing. There is kind of tools. But the thing is, what you want to do with that knowledge? Are you gonna start building program, or are you gonna apply a job, or just for fun, or to gain knowledge? So that's the difference basically. Because when you say I just wanna learn the programming, so you don't have to go deeper. You just need to broaden knowledge, just one by one, every part of it. So if you say I wanna get a job, so it's different. You may pick a field, for example, game developing, backend, mobile developing. Then you just start learning that kind of software, that kind of programming language. For example, programming language. For example, if I wanna develop mobile application, I can learn Flutter, and I can develop a mobile application. And when I need something, I can look for that. For example, you want to make notification component, so you can look at that and add in your program. You can build a mobile application, but with limited knowledge, because when you need something, you can look for it. When you need something, you can look for it. But when you say, I want to learn from everything, that's different.
Yeah, one more time. Sorry for that. Just I would like to ask you that. So are you suggesting learning programming from scratch with like a software language, development language? That's the way?
I mean, start from algorithms, just build something with any programming language. Just start building something, just, use it. It's like writing and reading. It's like when you read a programming language, you can do anything with that. When you write programming language, you can do anything with that. So just write something. And when you find yourself in a hard situation and access that, so you will become more experienced that way.
So you're supporting like learning by doing, actually.
Yeah, exactly.
All right. Because my opinion is a little bit different. I used to be a programmer as well, by the way. I used to be, not anymore. But well, my way was like learning from scratch, actually. Like, when I was looking at the documentation, that was my way. At the beginning, I learned about, like, I don't know, maybe I started with YouTube tutorials and stuff like that. Like for one scripting language, programming language, and I was like trying to build up things there. Anyway, if you start with YouTube tutorials, you will learn anyway, like building up something, so that was my way. But at some point I was like, okay, how it works this one and how it works that one, check the documentation. In the documentation, okay, so I'm developing this code, but how computer understands the language that I develop? You know what I mean? Like how how I can say like echo hello world or print hello world, and computer can do that. Like, for example, can we teach English to computer, like, and computer can understand it or not, and this kind of things for programming, obviously. Yeah, that's another way. So I just digging down, learn the basics, and then ground up from there. These are two different opinions, I guess, Dasha, for you. So
For me, I want to add something more. For me, for example, you think too much complex. I think a much simpler way. If this works, it works. That's all for me. Because there is too many things to know. If you wanna, for example, I have been developing 8 years, so, and I'm still learning and still lots of things to know. But you cannot know everything, because for example, I entered this company like 5 months ago, and I changed my whole stack, and I start learning again all the tools. So you cannot learn everything, and software also living thing. So when you learn completely tool, so it will outdate when you learn completely. So just learn what you need, for my opinion.
all right.
Find the shortcuts.
All right. So that was a good suggestion for Dasha. By the way, Dasha asking actually video game programming. So what you can say about video game development? Like, which tools can you suggest to her?
There is two main tools Dasha can use: Unity and Unreal, and two main programmer languages, C++ and C#. And Unity and C# is much simpler, and you can get into easily. So I will suggest C# and Unity. So you can switch to bigger one, which is Unreal and C++. But there is too many options, so you can check that other one also.
Okay, I also wrote down this C# and Unity. And can you say, by the way, I need to add that after 5 minutes at okay, 8:30 in Istanbul time. So at the 30, guys, because we have different time zones here. At the 30, we're gonna have 5 minutes break. I would like to tell it from now on. Then we're gonna back. So for now, okay, we talked about C# and Unity, but also she's like talking about any sources that you might suggest to her. Do you have anything in your mind or any path for her? Station videos. Okay.
YouTube, everything you need.
Yeah, like okay. I don't know how it is for C# and Unity. I like documentations before and okay. There is another question as well. Thank you so much, Deborah, to translating it.
This question will take some time. So
but after we're gonna okay. Woo!
this question will take some time, by the way. So maybe we wanna answer after the break.
Yeah, after the break.
How computer works.
By the way, we had a really big like upgrade notification from Zoom. Deborah just warned me. I just closed it down. I didn't know that it was a stream as well. All right.
That's
But
the reason for break.
no, we have 2 minutes. Just what I would like to say, Dasha, the documentations in the past was much more like for engineers, Today, much more like for makers. What the distinguishing between it, like today, documentations when you got in them, you can see much more like the way that Mustafa just explained. Like learn by doing things one by one. So that's why that's why you may use like documentations at the beginning, official documentations, just you can write like I guess Unity documentation or C# documentation and check them out. One more thing might be you can go to YouTube, and you can search tutorials for that, like from Hello World to Go. These two ways might work for beginning, but these are the two main technologies you may use for development, game development. By the way, Umut made a comment. I don't recommend C#, by the way. I will ask you to write some explanation for that. Let's make a break right now, 5-minute break. I will ask to Umut to make an explanation for that. And also for Banan's question, we're gonna answer it after the break. Thank you so much for all of you. You're here. So after 5 minutes, we're gonna continue. So thank you for Umut for sharing this. Thank you for the feedback. Never mind. Umut already answered more to Dasha's question actually, and Dasha took the notes, it seems. Thank you so much for additions, Umut. This comments a little bit for not for the beginners, but for seniors, I believe. But thank you so much for these addings, and Dasha will benefit of it a lot. Umut is another senior developer, by the way. So Dasha, you may really consider to Umut suggestions also. So as we skip this one, as we finish this question, we can continue with another question, which was, how does the computer know what I'm asking it? In parentheses, when programming. It's a great question actually. How computer understands when we type some programs, some codes, and how computer obey on it, how we make it possible.
Okay, let me start first. Then you can continue with the program side or another view. I may look for programmatically electronic side.
Yeah, don't worry.
You can
ask a lot of questions to you. To
correct me if I go too much deeper.
No, it's not about correcting, but I will ask a lot of questions to you about your explanation. I feel then hope you can understand that.
Okay.
Continue. My drop down.
First of all, okay, let's wait.
No, please continue. It's here.
Okay. First of all, everything for the computer is instructions. Everything you type, everything you say, everything computer sees with webcam or another way, everything for the computer is instruction. So you give commands to the computer what it does. You say, move my mouse cursor right top of that. Click on web page and go that website. And you may think lots of things like this.
So these are made with devices. Is this also I don't program the things for that? So, but okay, how it understands this is another question. But how it understands coding things, I'm a little bit confused here.
Okay, let's start simple. The most basic computers. For example, let's take calculators. How calculators work? Because what we have in nowadays, what we have computers, is very developed ones. So it's very complex, very developed, but it's gradually increase in that way. In first computers in 1940s, 3 rooms, big 3 rooms, and it's really there is real wires coming from the one component to another component to computer works. So let's think simple. How calculator works. And when we say calculator, we can look much simpler way. For example, we have not the computer, but we have circuits in our house. For example, this light is a circuit. When you click on it, it turns. It turns on. When you click, it turns off. This is also an instruction for the light. You say open and it's opening. You say close and it's closing. You know, there's a state, and you open and you close. And you can think, for example,
So when
in
we
the
develop actually something, when we write a code, so computer somehow understands that this part is still in a black box right now, but maybe go down deeper in that there as well. So it's actually switching on and off. Something's in the really in the hard drive or somewhere.
Actually, yes, it is. For example, in the CPU, CPU is a central processor unit for the computer. You may think it's brain of the computer.
AMD, this kind of things are that ones are CPU, right?
What, how?
The brands like Intel, i7, AMD, blah blah. These are the processors, right?
They are brands. They are brands. Yes.
This is what we are talking about, right? Like
yes.
CPU, that part actually.
Yes. And when we say CPU, it's like brain of the computer. It does everything. Computers work. It's a circuit. How circuits work actually with electricity. Everything in computer works with electricity, and there is really amazing invention behind the the circuits. When you look at the computer's history, it starts with transistors. OR gates, XOR gates, AND gates. You can build anything. Actually, all your code, binary code.
Okay,
you are right. Okay. What I'm saying is, what I was saying.
Like you were sisters and stuff, but okay, I guess we are going so deep that like we cannot.
We are losing our path.
Yeah, so what I understood from here, this computer has some parts. Like there is a CPU, there is, I don't know, where the code stores. It's not in CPU, I assume, it's somewhere else, and computer reads these codes, and like it changed something in the CPU, like some switches, like our light switches at home, So make some works there, and we see the like end result on our screen or something like that. This is what I understood. Is that right so far?
Yeah, I remember what I was saying. Umut, thank you for reminding me. I was talking about transistors. I will basically explain that and close the the subject. Transistors is the electronic parts on the board. They are really small because we made it, but in the back time they are really big parts, like this big, and it was really understands how electricity behaves. So you may instruct a transistor. For example, you may count, for example, 1 to 10 with basic electronic parts. You may calculate, you may multiply, you may additions, you may subtraction, you may we used to learn logic in our high school, so XOR, OR, and you may do this kind of operations with logics, with boards, electronic boards. So when you take this big electronic board and make it really, really small, that will make a CPU. So you may instruct you may say, anything for the computer. In the first time, computers were used to, landing the spacecraft, computing the distance for the basic calculations. For that demonstration, computers were built. So after that time, they were evolving. They are evolved that much. So you may think computer as a calculator, and you may think calculator. You may put another feature on the calculator. For example, calculator can save your previous entries.
Before we add more features on that, I would like to interruption. So what I understood from here, actually the switch at home that we have right now,
yes,
like it's kind of how you call is transistor, something like that. Basically the same.
It doesn't have transistors, but it is a circuit, closed circuit, and it is really basic, most basic form of the computer.
Okay, so like it's kind of a, all right, so we have a lot of this kind of switches in the CPU, somehow in the computer.
Yes, and that means something for the computer, because computer behaves the state of the switches. For example, if one of is on, one of them is on, computer behaves that differently. You may think, for example, in the computer.
So this is okay. I understood right now. So in the CPU we have a lot of this kind of circuits. So what the state is on or off. I feel like this is related with 0 and 1 that we hear always.
Exactly.
Okay.
High voltage, low voltage.
Okay, I don't know what you are talking, but yeah. So I high voltage, low voltage. I don't know what happens, and it become high and low. I don't know. I don't discriminate voltages, but yeah. Thank you. And
and differences between voltages are gigahertz.
Okay, I don't
CPU
know.
lock.
Okay. Whoa. Okay. Wait for now. I guess this is too much. So what I would like to say, these switches that we have it in our home, basically there are a lot of them in CPU. So it is like, do you remember unnecessary machine? Do you know what's that?
Here the guy from Instagram.
No, like the unnecessary machine is some kind of like box, and this box has like few switches on it, 4 or 5.
I know.
Like when you turn on the switches,
Blanket.
One hand comes up from the box and is just switch them off. So basically, like what I'm thinking right now, there are a lot of switches like that in the computer, like some small tiny way, and it's kind of like it's switch up and down and up and down, and it means something. So actually, this reminded me, what was that? This Morse alphabet is like, it sounds like that. It's kind of a source alphabet.
No, it's kind of different.
But like
it is like translation of hash code kind of things,
Okay, I don't understand. This is another language. It's not a Morse alphabet or language that built up based on that. But I'm asking that this is kind of these like combinations of turn on, off, blah blah whatever. This is actually some kind of language that computer uses, and it looks like, sounds like Morse alphabet for me. Why? Because in the Morse alphabet there are like laws and long like connection. So it sounds like to me, another really deep engineering information come up from Umut. All right now, but thank you so much for your participation.
You will have to stop us.
Yeah, you made the half of the comments, and thank you so much for your participation there. Like these switches, like overall make some kind of sentence like for us, like in a Morse alphabet?
It is not kind of sentence, it is different for the CPU and different for the, data. The CPU understands, these are basically, for example, in 32-bit computer and 64-bit computers there are, right? For example, let's take 64-bit computer. There are 64 lights, for example, 64 bits on the, one line of instruction set.
So when I actually like download a game, sometimes it says, "Oh, this is for 32-bit. You cannot run it." It's
different length of line.
So that's related with CPU thing.
Exactly. Exactly. For example, in the past, the people fit in the instructions fit in the 32, and that they were enough for them. But nowadays we use for 64, and just for line for instruction we use 64 bits. You can think that way. CPU takes these lines one by one and behaves like that. For example, in 8 bits, tells CPU what to do with that line. There is 64 lines, and for 8 line, tells the CPU what to do with that. Our CPU sum the two, for example, two values, or multiply them, or store somewhere else. For example, you can do anything with 8 instruction sets. Anything.
Okay, before we go there, all right. Actually, this is what. Okay, I guess I understood. Yeah, this is basically an alphabet for the computer, isn't it? The computer has its own alphabet. These are just a combination of on and off, on and off.
It is, but the point is this: how computer behaves based on the alphabet, right? The question is this, because you can write anything, but how computer understands this? The computer understands.
Go. I will handle that.
Okay. For example, computers has circuits based the operation circuits. For example, one circuit just multiplies. One circuit just does additions. One circuit just moves the data somewhere to another where. These circuits are electronic parts, basic electronic parts. You can build that parts in your house as well, like just gates and transistors. So, CPU, are you with us?
Yeah, I'm just handling this.
Bad comments.
Yeah, not bad comment, but it's not the place,
Not related.
Yeah.
Okay. CPU takes this instruction set. CPU takes this instruction set and redirect them. For example, you may think CPU as a city. There is a warehouse and there's multiple packages coming, and you direct that the package where the package must go. So the packages are informations. The directions, you may see the roads, for example, you may see circuits. So are that packages, for example, when there is an addition, you direct the information to addition circuit. So you will have a.
Okay, at this point, I have a question. We are going so deep in there again. So let's get the main point first, which is how computer understands what I am doing. So what overall I understand what you said from what I understood overall from what you said is we have a CPU. There are some switches in there. These switches goes up and down, and this combination means something to computer, and it goes in that way. All right. So the question is how the codes that I wrote on the computer, let's say you talk about Unity C# here. I developed something in C#, really simple thing. It will say just hello world, it's like a pop-up. That's the first lesson for whole programming languages that we can find online on YouTube and or in the documentation. So how it happens that these codes that I wrote, for example, if I say echo or print hello world, this P goes down and switch up something or down, like how this works actually.
Okay, basically there are, compilers who turns what you write, what you code into the machine code, into the assembly, into the machine code, zeros and ones. The compiler is compiler that
zeros and ones. I was expecting for that.
yeah, zeros and ones. Like assembly and zeros one, basically the same thing actually. So you write, for example, hello world in different languages, and there are interpreters and compilers. For example, you can say that translators, because they translate what you write into the machine code, and the machine code actually understands zeros, ones, zero and ones. So that's the way.
Okay, where these compilers comes from? Okay, we have a translator there. This translator understands what we wrote in there in C#, and translates that into the machine code. These magic zeros, ones, and these zeros and ones actually.
Matrix coming and going from everywhere.
Yeah, who is this compilers? How we can contact to them? Do you have any compilers? Like, can you give us a number?
Compilers, actually, there are programs as well. Machine code for zero, and you can translate zero and one into the A B. A is a
okay.
a opcode.
We'll discuss it later because this is really deep engineering topic here. They're discussing. Please, after the call, after this webinar, please call Umut, or Umut can call you and you can discuss about it, guys.
I mean,
thank you so much.
I may say wrong. For example, if I said, basically the same thing, it's not basically the same thing, but you can directly translate assembly to machine codes with your hand. You don't have any compiler or something.
Okay, let's talk about what's this compiler. Who is this compiler?
In the first, humans were compiler because they wrote the zeros and ones. But after that, they wrote some codes to do their business. For example, in nowadays we write AI to build codes, but in the back time they wrote compilers. They wrote compilers to because machine code, zeros and ones, assemblies are really low level languages. You have to say everything, really everything to computer. But in nowadays we just write multiple lines of codes and it does everything. How is that? Based thanks to the compilers, because it takes all instruction sets and translates into machine, so machine understand more.
Okay, I
machine understand more.
What compilers does. I'm asking, what is compiler? Okay,
Compiler is a program. They are programmers.
Software
yes.
program.
Yes.
And
yes.
who developed that? Can we develop compiler as well? Can I create a language like? Yeah, no.
Yeah,
that's overall question. Like,
you are.
Can I? Okay, so I can make a language like a Yeats language.
Yeah, of course.
And I can develop compiler. So okay,
it's not that hard, by the way. Creating a language is not that hard. Okay. Creating a good language is hard. The philosophy behind it is hard, not the language.
All right, I do understand that as well. So my question is, if the compiler is a software,
yes,
and
translates the software and translates the software,
translates our codes to the machine language. Machine language does not need a compiler. It's like a God language or something like that, and how the first compiler developed. So which compiler compiled the first compiler?
They were humans.
What do you mean by that?
Humans were compiler at the first time. They were compiling the things. For example, they wrote they wrote lines of codes and translate them zeros and ones. Basically,
I didn't understand
in the first time they don't have they were cables. You have to plug the cables in certain position to mean something.
In the CPU.
Did it make sense? In the circuit. Check punch cards. Yeah, punch cards. For example, that I think that in a space mission there were errors based on the wiring. They wired put somewhere else.
This is a computer. Yeah,
yes.
Right. It's a computer. So there is I developed something on this, and let's say it's a JavaScript or C#, just we talked about. This is the computer. How the first when I develop something, for example, C#, when I click on compile, I assume so there should be a button to say compile. Then people comes and change the wires in my computer.
No.
So how C# compiler developed? What or who compiled C# compiler?
I didn't get your question. I answered. The breadboard some wires are open.
I don't understand.
Exactly.
Breadboard, some wires are open. You put holes in the card connection circuit. Okay, I will check that out. Thank you so much. By the way, we have really less time left. Let's stop in here, put a dot in here in a punch card, maybe. I don't know where.
What is punch card? Next time.
Next time you can check the a card which is not the punch card coming there. So answer of the question overall, when we develop a code, there are compilers which translates this code to the machine code, and computer can understand. There are some logic gates in the CPU, and CPU can understand the machine language, which is zeros and ones. I believe this is what I understood. Please correct me if I understood wrongly. And we have compilers which translates the programming codes to this machine code, which are zeros and ones. So that was the answer of your question. I don't know if
may I have last addition?
Yeah, please.
You may think computers levels of complexity. For example, there is low-level complexity. You write hello world and it shows something, and there is a little bit deeper, a little bit deeper, a little bit deeper. When you go deeper, computer understands much more, and you have to do more work because you need to instruct line by line. So this between these layers, there are some instructions that's how the layers translate between. For example, you write hello world and it turns something, it turns something, it turns something, it turns something to zeros ones.
Okay, this much more. This actually it was a good addition. All right, so there is a compiler developed with zeros and ones already.
Yeah.
And this is an X language, was a little bit more easier to develop something with that. And they developed a compiler, for example, C# compiler with that, and then in that way we can develop C#, compile that compiler, I don't know, maybe directly compiles it to zeros and ones. Compiler is a translator, as far as I understood here.
And additional, please complete.
because we don't have
Oh,
time.
let me put a sentence, last sentence.
Please, like, thank you so much, but we have no time. You know, it's going down. We need to say thank you and stuff like that. So thank you so much for joining today. Your explanations. So we can talk about it more later. This was the end of today. Hopefully, you got the answer of your question, bananen. So that was our first call. So that was our first webinar. So we had some technical issues. We had a maybe issue with the topic and stuff like that as well. But thank you for waiting till this time with us. Thank you for your comments. Thank you for your questions for all.
I
Please.
think we may give a gift for our viewers or joiners.
Okay. It seems that we have there's a gift for the joiners who like to stay up in that time. What's the gift?
The motivant.
Alright.
They can be first users or first users, and they can reach lifetime, you know, the premium features.
Perfect. I would like to do that as well. Thank you for our today's sponsor, Notivant, as well. And we can be the early accessors for the app. How we can reach out? Tell us.
You may drop your emails, or they can send the emails directly to. Can I comment? Can you leave my email, Notivant's email, hey@notivants.com, so they can mail? Notivant.com. They can email, and we can give promo code them.
If you like to be early accessor, please send an email and see for your. They're gonna get a code or URL, but they're gonna get
URL basically.
URL. All right. Thank you so much for that as well. Thank you so much to you.
Thank you for having me.
And Notivant as well for today.
Welcome.
And thank you for all to join also. Hopefully we can continue this webinars and stuff like that. Please text me on Instagram what you'd like to hear more and stuff. So for now, see you till next time. Bye-bye.
See you. Have a nice day.